50. So there's the F and the O. There's the first and the outside. And then I'm going to do my inside two terms. So I'm going to multiply the second term by both in the second bracket. The 4 and the 4 together give me the positive 16. And then I'm going to have my 6 and my 7 multiplied together are going to give me the 42. So there's the inside, and then the L is going to be the last two terms. So 4 times the negative 1 is going to give me negative 4. The 6 and the 5 is going to give me root 30. So hopefully you guys remembered how to multiply those types of things, and normally you would have seen them with maybe like X's and Y's, but now we have radical signs in there. So at this point I need to figure out if I have any perfect squares I can simplify. So 70, are there any perfect squares that go into 70? Just 4 go into 70. I split that up into 4. No. Can I do anything with the 70? 25 doesn't go into 70. 36 doesn't go into 70. So I'm thinking that the 12 times the square root of 70 is as simple as it's going to get. How about 50? Is there anything I can simplify the 50 down to? 50 I know is going to be 25 times 2. So I'm going to simplify that here in this next step. 42. It's the largest perfect square that goes into 42. 42. If I divide it by 4, get 10 and a half. 42 divided by 9, that doesn't work. 42 divided by 36, that doesn't work. So it doesn't look like there's any perfect squares that go into 42. So I just leave it as square root of 42. And then 30. Are there any terms that go into 30 that are perfect squares? So 4 doesn't go into 30, 9 doesn't go into 30, 16 doesn't go into 30, 25 doesn't go into 30. So I have 4 root 30. So I'm just going to simplify this 1 that ended up being 50, and then I'm done. So I'm going to just carry everything down. 12 times the square root of 70. In this case, I don't have to worry about the 3 out front quite yet. The square root of 25 is going to give me 5, and then the 5 times the 3 are going to give me 15. When I get here, I need to say, are there any like terms? I have root 70, I have root 2, I have root 42, and I have root 30, and none of those are the same. So I can't combine any like terms. It's a big mess of an answer, but that's it. That's as far as I can go. I've done the multiplication, I've simplified my radicals, and I've tried to combine any like terms. So that's it. That's my answer. And sometimes it's going to work out that way where it's not really wonderful and everything works out and you just kind of end up with a mess of an answer. I have one last one to do, and I'm going to apologize to you guys because I know I didn't leave you enough room, so you might want to just flip your page and put it on the back, but I thought if I had it on the back side of the page, you would just miss it altogether. So I put it on the front side, but I suggest you rewrite it on the back because it's going to take some work here to get this little fella done. If I had something like, I don't know, x squared, I would write it as x times x. Anytime I have something squared, I'm multiplying it by itself. In this case, it is absolutely no different. I'm squaring everything inside the brackets. So what I'm going to do is I'm just going to rewrite the question as 2 times root 5 plus root 6 times 2 times root 5 plus root 6. I'm just going to write it out twice, because that's what squared means, multiplying it by itself. Everything in the brackets gets multiplied by itself. At this point, I'm going to remember the FOIL, which Abby has never heard of before, but she's really good at distributing, so she doesn't even need to think about it that way. And I'm going to see what happens. So I learned it as first, outside, inside, last. So I'm going to multiply my first terms together. I'm going to multiply my outside terms together. I'm going to multiply my inside terms together, and I'm going to multiply my last terms together. FOIL. First, outside, inside, last. So let's go ahead and do some of that multiplication. The first one here, 2 root 5 times 2 root 5 is going to give me 4, and the root 5s together are going to give me root 25. So that's my first. My outside is going to be a 2 times a 1. Which is going to give me 2, and then root 5 from here, and the root 6 from here, together gives me root 30. And then I'm going to do my inside, so root 6 times 2 root 5 is going to give me 2 times the square root of 30. And then my last is going to give me root 6 times root 6, or plus root 36. So one step out of the way, I've done my multiplication. Now I need to think, I can do two things. I can either simplify and then combine like terms, or I can combine like terms and simplify. Or if you're really, really on the ball, which I don't recommend because it's easy to make mistakes, you can simplify and combine them like terms at the same time. But probably not the way we want to go about this. So I'm going to simplify first, and then I'm going to combine my like terms. First thing I notice here is my perfect squares that I've run into. Because I multiplied root 5 by root 5, I got root 25. And then because I have the root 6 times the root 6, I get root 36. So those are both perfect squares. So I'm going to just simplify my perfect squares first. Root 25 is actually 5. I have 2 times the square root of 30, plus another 2 square root 30s. And then root 36 is just going to give me 6. According to order of operations, I need to do my multiplication before I can do my addition. So I'm going to have to do this 4 times 5 out front here. 4 5s should give me 20. Plus 2 root 30, plus another 2, root 30, plus 6. All right, now that I have simplified, there's no perfect squares that go into 30, so I can't pull anything out of there, simplify that any further. Now I just need to combine my like terms. So if I look, I see that I have a couple root 30s, and I have a 20 and a 6, which can be added together. So I'm going to add my 20 and my 6 together to get 26. 2 root 30 plus another 2 root 30 gives me 4 times the square root of 30. And that is it. I can't add the 26 and the 4 together because those are talking about different things. 26 is just an integer, and then the 4 is saying you have 4 groups of root 30. So those are different. We can't add them together. There's no perfect squares that go into 30. So I'm done. There's nothing else I can do there. So you can kind of see how adding and subtracting is important to kind of master first. And before we can even do the adding and subtracting, it's kind of important to make sure you've mastered simplifying your radicals. Are there any perfect squares you can pull out? Are there any perfect cubes you can pull out? One thing that I should have mentioned in this lesson that didn't come up is that if I had something like, I don't even know if you'll get examples like this, 2 times the square root of 30, maybe times 4 times the cube root of, I don't know, 7. When you end up with these sorts of things, what you can do, I'm just kind of guessing that this is going to happen. I don't even know if it's going to happen in the questions or not. You can multiply the 2 and the 4 together and you get 8. And then just leave it as root 30 times the cube root of 7. You can't multiply square roots and cube roots together quite yet. So that's kind of something that I don't know will happen, but I'm just kind of thinking if it does. Taylor's asking a good question here. How do we know when to use FOIL? And can I use it in every question? Taylor, when we use FOIL, we're going to have questions that kind of look like sort of 2 things. So if I had like x plus 2 and, I don't know, 3x plus 7. These are called binomials. So I have polynomials with 2 terms. Anytime I have 2 terms inside the brackets and I'm multiplying 2 sets with 2 terms together, then I'm going to FOIL. And I can go first, outside, inside, and last. That's how I learned it. On the other hand, if you had a question like this, 2x, let's use radicals, I guess we're using radicals here. 2 root 3 times 3 plus 7 root 5. FOIL doesn't work for a question like this because I don't have anything in front here, so I'm just going to distribute or feed my chickens and multiply the 2 root 3 by the 3 and then the 2 root 3 by the 7 root 5. So when we have binomials, 2 binomials, like the first thing I wrote here, these guys, then we can use FOIL. When we have just one thing and then 2 things, then that is called using the distributive principle, and we need to multiply by both of those and feed our chickens. Like D wouldn't work. Up above here, let's go back to D and have a look. Yeah, so exactly, letter D, example D, that isn't a binomial. There's only 1 term each. So when we have 2 terms and 2 terms, we FOIL. We have 1 term and 2 terms, we distribute. And then if we just have 2 brackets with only 1 term and 1 term, we just multiply those together. Hopefully that's a little bit clear. I'm just going to peek in at the learning guide. If anybody has any questions about anything I did in the lesson, you can fire away. Try to give myself more time. It looks like I succeeded in giving myself too much time, which is fine. Right as entire radical, so you guys have done that. Number 8, I told you not to worry about. We did 9 and 10. So this is what we're going to be looking at today. The first one here, like terms, is just adding things that are the same. That's pretty self-explanatory, I feel. Adding and subtracting radicals, this is just combining things that are the same. So let's maybe pick a different one. Like this guy here, maybe not that guy. Here, we have 5 root 3's and then we're taking away 1, so we're going to end up with 4 root 3. I'm going to put a little star next to F, and I'm going to write a little note here. Simplify first. So it's important that we simplify these things before we combine them. And then I think everything after F, it'll become important that you simplify first. And what do I mean by that? Like H here, I have the square root of 50, which can be written as the square root of 25 times 2, which is going to be 5 times root 2. So make sure you're simplifying these. Same with 18, you're going to get 9 and 2. So that's where you're going to run into problems there. Adding, subtracting. Number 2, same process except with cube roots. So don't get freaked out by the cube roots. It's the exact same thing. It's just your roots are going to change. So instead of doing 4 and 9 and 16, you're dealing with 8. It's 2 cubed is 8. And then 3 cubed is 27. 4 cubed is going to be 64. 125 is 5 cubed, and then 216. So these are your perfect cubes. You might want to have those handy for doing these guys. Simplify first. Multiplying and dividing radicals. Simplify each of the following. So there's all multiplication there. Make sure you distribute these types of questions. And then these guys are our FOIL. For like K. That's the first FOIL. Did I not do any division of radicals? Well, that's not good. Let's do a couple of these. Hopefully you guys have your learning guide out. I'm on page number 10. And maybe I'll do a couple. Maybe that's why I had so much free time, because I didn't do any division questions. Same as multiplication. The rules. And Alex, I see your question there, so I'll get to that. I promise. Square root of 6 and 3. Are there any things? Imagine I just had a question that said 6 over 3. Is there anything common between 6 and 3? What can I pull out? So 3 goes into 6 2 times. So 6 divided by 3 is going to give me, you can think about 3 going into 6 twice, root 2 over the square root of 1. What is the square root of 1? Square root of 1 kind of gets tricky because it kind of gets forgotten about with our perfect squares. 1 times 1 equals 1. That is a perfect square technically. So I can take the square root of 1 and I just end up with 1. So I'd end up with root 2 over 1, and I can just write root 2 over 1 as just root 2. So that's the first one. Maybe I'll do B with you guys as well. So I'll write this as root 2 over root 1, because I can pull a 3 out of both of those. Root 2 can't be simplified any further, but the square root of 1 is 1, and I just leave it as root 2. 14 and 2. What's common between 14 and 2? Well, I can pull a 2 out of the bottom and end up with 1, and 14 divided by 2 is 7. So I get root 7 over root 1. Same process as before. Root 7 over square root of 1 is 1, and I end up with root 7. Let's look at E. I'll leave a couple of them for you guys to do as practice. E. There are some numbers in front of our radical sign. So when we're dealing with questions like E, I need to deal with the numbers out front separately from the numbers underneath. So I'm going to deal with the radicals separately from the numbers out in front. So I need to think, are there any common terms between 5 and 10? And yes, I know I'm going to divide 5 by 5 and get 1. 10 divided by 5 is going to give me 2. And then common terms between the 15 and the 3. So I know 3 goes into 3 one time. 3 goes into 15 3 times. So I'm going to rewrite this. I don't have to write it as 1 times the square root of 3, but I'm just going to put it in there just for simplification purposes. That's going to be all divided by, and 2 times the square root of 1. So if I just get rid of my 1's, I end up with root 3 over 2. So there's 3 there for you guys to do as practice. I really apologize for not putting any of these in the examples. I guess I just simply forgot about them. Oops. Maybe look at a couple of these ones. Simplify each of the following, leave in simplest radical form. Right here where it says rationalize all denominators. This means get rid of radicals in the bottom. We can never leave an answer with a square root sign in the denominator. Just one of these math sort of things that we do. So let's pick one. Maybe we'll pick C. I'll do C for us. So we have 6 times the square root of 10 divided by square root of 3. All right. Now, rationalize the denominator means no radicals in bottom of fraction. Gotta get rid of the radicals in the bottom. How can I do that? It's kind of like when we're dealing with simplifying fractions and those sorts of things. I need to get rid of the radical sign in the bottom. And the easiest way to do that is multiply by whatever is there. And if you think about this, if I had something like root 3 times root 3, it's going to give me root 9, and the square root of 9 is just 3. So I know if I multiply the bottom by whatever is there, I'm going to end up getting rid of the radical. Abby's pointing something out here. The dividing radicals question we did is actually square root 5 over 2, not square root 3 over 2. What did I do then? Square root 5 over 2, not square root... Oh, 3 goes into 15 5 times. Thanks, guys. That was a silly one. Thanks for catching that. Thank you for pointing out my mistake, because everyone would have gone home with that and been like, I don't understand where this is coming from. Back to the question, letter C, rationalizing the denominator. When I do multiplication with fractions, if I do something to the bottom, I have to do the same thing at the top. And why can I do it this way? Well, what is root 3 divided by root 3? Or what is 7 over 7? Or what is 152 over 152? These things all just equal 1. So I'm just multiplying by 1. I'm not changing anything. It's just really multiplying by 1. If I'm multiplying by root 3 over root 3, I'm multiplying by 1. So what I'm going to do is I'm going to do my multiplication. 6 root 10 times root 3 is 6 root 30. And on the bottom I get root 3 times root 3 is the square root of 9. So 6 root 30. And then the square root of 9 is 3. Once I get the 3, I know that I need to simplify these, and 6 divided by 3 is going to give me 2 times the square root of 30. And this is all just over 1, but I'm not even going to write the 1 in because I don't need to. So let's do one more of those because they can get a bit tricky. Maybe let's do G. I'm going to do G over here on the left side. So root 7 minus 3 over root 3. Same root 3 on the bottom, just a coincidence. So what I'm going to do is I'm going to multiply both the top and bottom by root 3. There's nothing I can simplify here. Root 7 minus 3, I can't combine those. The root 3 on the bottom, I can't simplify anything there because I'm not going to get any whole numbers. So I'm going to multiply both the top and the bottom by root 3. Now, if you think about it, on the top, I have to multiply the root 3 by the first number, and I have to multiply it by the second number. On the bottom, there's only one term there, so I'm just going to write it down as root 3 and 3. So root 3 times root 7, 3 and 7 gives me 21, so I have root 21. And I have minus 3 root 3 now, multiplying by both those. And then on the bottom, I have root 3 times root 3, which is just going to give me root 9. Root 21 minus 3 root 3. And then I know I have a 3 on the bottom. Any perfect squares that go into 21, what do we think? 21, 7, and 3, nope, nope, and nope. No perfect squares there. I have this 3 on the bottom. And I could write this separately as root 21 over 3 minus 3 root 3 over 3. Because the division means I'm dividing both of my terms on the top by the 3 on the bottom, so I can write it as two separate ones. The only reason I do that is the 3 and the 3 divide out, and I can end up with just the root 3 there, because 3 divided by 3 is going to give me, I could write it as root 3 over 1 or just root 3. I'm going to leave it like that. Now, I kind of realized that you guys might have a few questions about those ones next day. And I'm fine with that, because that's about as tricky as these questions get. The idea is to get rid of any radical signs on the bottom. So try the other ones that I didn't go through, see how you do, and let me know next day. We're finding the area and the perimeter. So area is just length times width. If I wrote the question as 4 root 2 times 3 root 2 plus 2 root 3, you're just going to distribute for the area, length times the width, and you should be good there. And Alex's question, which question did you ask, Alex? Last question on page 11. That is page 11, number 6 here. The rectangular prism has the following dimensions. Find a simplified expression for the volume. So we know volume of a cube is length times width times height. We can call this length, we can call this width, and we can call this height. So we're just going to multiply all of these things together. This is a triple woozy doozy. That's not its official name, but that's what I'm going to call it for today. I'm going to have length root 10 minus root 2 times width root 10 plus root 2 times height root 10 minus root 3. Holy cow, that's going to be a lot. I don't have a fancy acronym for multiplying 3 binomials. I guess they're not binomials, they're biradicals maybe. I don't know if they even have a name. Probably do, I just don't know it. Multiplying 3 things with 2 terms multiplied by each other. So what I'm going to tell you is to do it in 2 steps. You actually find something that interesting happens here. You're going to do your FOIL first, outside, inside, and last. And what you should do is just bring this 10 root 3 down. So you're going to end up with this big mess of stuff. A bunch of these terms are going to actually cancel out on the inside, just kind of the way the question's set up, skillfully set up. So you're going to go 10 times root 10, you get square root of 100, which is just 10. The middle 2 terms are going to cancel, and you're going to find that you should end up with, just off the top of my head, I'm thinking you're going to end up with just 6 here. Don't quote me on that, I'm just doing it quickly in my head. So all of that big mess of the first 2 multiplications is going to just leave you with 6. I'm thinking 10, 4, yeah. So then you're just going to distribute the 6 through the brackets. But I want you to figure out that on your own because there's a few steps in the middle that you need to show. So that's my time for today. Do as much of the booklet as you can. I have a feeling you'll have a few questions about number 3 here. You probably have a few questions maybe on the questions like 5 and 6. And then if you have them, I'll have time at the beginning of next day to answer any questions or review anything from the unit. If you can have a look at quiz number 2 from Unit 1 tonight, that would be great. And then, yeah, that's really it for this unit. So maybe attempt the quiz today if you're feeling confident with this stuff. If not, you can do it tomorrow after I go through the answers to this. You should have your review probably, or the learning guide here that I've just been going through. You should have that submitted maybe by the end of tomorrow, tomorrow night, or maybe Wednesday morning at the latest. I'll get you the password for the test emailed out to you, and then you can write the test when you find some time between now and Friday, or I guess Wednesday and Friday. Even Friday, because it's a Pro D, you'll have all day to do it if you can get the review in before that, and I can get it back to you. So that's kind of my hope. That's kind of the timeline. We still have to move on to Unit 3, so you don't want to leave this stuff too long. So I'm going to actually start Unit 3 next day, and that's kind of where we're at. So hopefully you don't have any pressing questions, and I guess I'll see you guys tomorrow. Mrs. Ward will be on with English at in about 5 or 10 minutes. So we'll probably put up 10 minutes and she'll start then. So go grab a snack, a drink, and see you guys tomorrow. Thanks.